Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo. Good morning, everybody. Welcome to our TESCO Tuesday. This presentation is for OSHA Title 8 meter testing safety. It'll be given by John Carroll, our Western Regional Manager. And without further ado, John, would you like to take over?
Yeah, thank you, Andy. Appreciate it. Good morning, everybody. Can you hear me okay? Andy, you got that?
Yes, I hear you perfect.
Cool. Well, thank you. We appreciate this. We set these up, I think, in the current conditions that we're all facing. We like to do a lot of these presentations at the meter schools that we attend, and we always enjoy doing them. We get really good feedback, so we appreciate your time. This is probably going to be maybe 45 minutes, so it won't take up too much of your morning. But we appreciate the opportunity. And when we set these up, I was asked if there's anything specific I wanted to cover. We got a whole range of topics. This one for me is something that I've seen develop, and I've watched it sort of growing a little bit over the past 4 or 5 years. So I don't know whether anyone else is familiar with this, but I thought we'd bring it to everyone's attention. It may affect you in some parts of the country more than others, but I think overall it's a good safety. And for our particular situation, it's because of the impact it has on testing, which is the critical part of this. So yeah, so anything we have, any questions, we can either leave them to the end or send them through to Andy. She can text me that and we can perhaps go through as we do that. But we should have enough time at the end as well to do any kind of Q&A.
And just so y'all know, that little chat box on the bottom right-hand side is where you can reach us. And right now, Ross had asked, did anyone receive last week's presentation? If you sign up through our website and your email is on our list, we do email out the presentation. So if you don't get that, please give an email out. You can send it directly to me at andrea.koch@tescometering.com, and we'll get you all a copy on that. And again, you can just throw it in the chat box too with your email, and we'll send that out to you as well, okay?
Thank you, Andy. Yeah, in this particular case, we're using like a WebEx service, and my screen is my whole screen, so I can't really see that sort of text box. So if you send it to Andy, we'll gather them together, and then we can make sure we get all the answers for you. So OSHA Title 8 and meter testing safety. For those who are not familiar, OSHA is the Occupational Safety and Health Administration. It is a federal organization, and there is obviously state regulatory requirements too. And Title 8 in particular is referring to the California one. And this is where I think it's an interesting situation that's developing. So to move forward with that, what we'll do is we'll have a little discussion about these as we go on later on. But initially, I want to cover some topics. And a couple of the topics I wanted to discuss is what is OSHA Title 8? How do we comply with it? Where you would see it, how does it affect us, and any kind of field testing issues. So later on in the presentation, we'll do a little bit more about how we test and why and how this affects us, because it does. And there are some implications to that. So the OSHA Title 8 is a particular one in California, and that's the one we're going to talk about today. But this is an ongoing federal and state regulatory requirement. So in the initial Title 8 documentation, and I will warn you, if anybody wants to look at this, I've got a link on the presentation material, and we can certainly send that to you. It is a pretty long document, so it will take some time, but I would focus on some of the sub-chapters that I've found for us, which are relevant to the electrical safety testing. So the safety orders in Chapter 4, they're based on, without a few exceptions, on the general industry safety orders. That's been pretty common in the US for many years. There's many sub-chapters in this, but the particular ones we're going to focus on are the ones related to any kind of occupational safety and health, which relates to, obviously any kind of worker safety in and around energized circuits. So a limited number of Cal ISO program administrations are in like these different chapters. But for the most part, this is really a practical and pragmatic approach to doing safe testing. It's not that this has never done before. The testing that we're talking about, my apologies, I've got to switch my phone off, of all people. I'm the guilty one. I get a strike against me. So this has been around for some years, and we have tested like this for many, many years. And I've been involved in the industry since I moved here from the UK in 2001. So it's been a long time, but I've covered a whole swathe of the country and seen this many, many times. So it's not like we've never done this before. But moving on, we have this particular index. Again, I'm not going to go through all of this. I just wanted to share with you the sort of complexity that's involved, but try to extract some of the simple parts of this that affect us in the utility world, particularly for this type of testing. So the title is related to the California OSHA specifically. And as we go moving through this, you'll see there's different conditions and regulations and ongoing implementations that they're trying to and have done within all the California utilities. So if you are from a California utility, you may be familiar with this. If you're not, then it's something to watch for. I don't think it's regulated anywhere else in the country that I'm aware of other than California at this point. But it would probably behoove you to just go and check with the state OSHA regulations to see if there's anything in there as well. Okay, so how do we comply? The main chapter that you want to be focused on when you look into this is the electrical safety orders, the ESOs, and that is subchapter 5. And there are low voltage electrical safety orders, which are very well documented in here, including all the work procedures too, which I'm sure most, if not all, the utilities will be familiar with. I mean, we're all familiar with PPE. We're all familiar with the requirements we have to be safe and with the appropriate PPE clothing, for example. But there are different categories, as we know. There's, low 4 cal per centimeter squared suits and shirts, jeans, and so on. It goes all the way up to 40 cal, which is a pretty heavy suit. I've not used one in anger myself. I've not actually been into a panel with them, but I have wore some of these, and we'll give you an example of that later on. So they are kind of clumsy, but they're very protective of you. So it's a procedural approach to doing the testing. So let's have another look at this one. So what we're looking at here is the PPE side of this, which we talked about a little bit. And we're not a PPE company, as I say. We do have a lot of software in our products that actually manages and monitors a lot of PPE equipment. So if there's anyone's interested in that afterwards, let us know. It's a meter software manager that we have that will give you asset control. And it is important to have that because you need to be sure that everybody who's using any of these items are thoroughly tested. Gloves, hats, face masks, face shields, everything else. If there's any holes in them, they need to be discarded. So this is just another overview of the electrical test intervals that we see for the majority of the standards. And most utilities do either use a subcontractor company to do this or even in-house. There's a lot of different situations where they can do that, but essentially, taking care of that equipment will take care of you in the event of any kind of incident. So minimum approach distances, this is where we would see it in a sense that this is something we have to be aware of. I've given you a pretty big website link there that you can go and check out for your own particular area where you live and where you work. And that is relevant to that particular area. But this is part of the overall procedures that we have. And in most cases, these are the minimal approach distances. And the approach distance is the critical component here because we are talking essentially about arc flash conditions. And there's a whole topic. I don't do that. I'm not an expert on this, but I have been involved in some of the testing. And we do look into a lot of equipment that we can provide that helps you to understand the arc flash conditions that we have. We have products that do hot gap indicators on the sockets themselves. That doesn't require you to have minimum approach distances, but nonetheless, it's a relevant component to why we're doing all this testing and why we're approaching these very carefully. And as you can see, we've got up to 300 volts here, which typically is a 277 circuit, 120 to 277. And then we have the 301 to 600, which brings into being the 480 circuits. I was doing a test the other week recently where we were just about to go into a cabinet, and then the meter tech said, "Whoop, sorry, we just realized we can't go in the cabinet." And I asked them why, and then this topic came.
Can you hear me, John? I think you just went out.
Oh, sorry, did I?
Yeah, the last 2 seconds maybe.
No, I'm still on as far as I can see.
Okay.
Hang on a second here. Can you hear me okay? Hello?
Oh, it was? Okay, mine just went out then.
Oh, I can hear you. Can
Yep.
anyone else hear me okay?
Yep, you're good. Everybody's giving me
Okay.
a thumbs up here.
Very good, John.
Yes, it's the technical vagaries of what we're living in the moment, isn't it? So let's just jump back into that same slide there. Okay. All right. Well, yeah, text me, Andy, if you can on my phone. That's probably an easier way to do it if there's a problem, but we'll press on. Okay. All right. So looking into this a little bit more, and again, I'm covering this topic initially to begin with because this is relevant. This is where all the regulations, requirements, directives, this is where they're all either going to become a legal legislative document at some point or they're just recommendations. But either way, it's really wise to just refresh these and go back in time and look at some of these too. I mean, these are all obviously safety issues that we all care about. So essentially, the title 8 there is your table of contents. Without going through that whole website, if you go to the next page on that, there's that subchapter that I've highlighted for you. And that, at this point in time, if you're in our industry, is probably the most relevant. There's lots and lots of them, which may or may not apply to you, but this one certainly would do if you're in the electrical industry of any kind. And so this subchapter 5, a lot of interesting material in there. Always worth looking into it and seeing what the situations are with that. But once again, it really is the state decision making, I think, on how they roll this out and if they do. A lot of the testing that we're talking about here, as I say, has been done for many, many years. This is nothing unsafe. This is a very safe procedure. And many of you out there who go to the meter schools, and we see you and we work with you all, and we have good commentations with you. We see all the time that these tests are pretty common. And every single day there's cabinets being opened and every day meter sockets have been removed and replaced. So this is a procedure that's well trained for. There are all professionals out there doing this, which is why we see a very, very small amount of problems and incidents. And so sometimes I look at this as almost trying to fix a problem that doesn't exist. However, it is a safety aspect to this. It is arc flash, excuse me, and we need to pay attention to it. We can't be cavalier about it. We have to be sure. And if there's any doubt, then you don't do the test. It's as simple as that. I mean, you don't do it for rushing it. It's not a race. I mean, you can always come back and do it another time. So that's kind of the overview of the sort of OSHA requirements and some of the OSHA regulations on here. And so what we're going to look at now is whether we can see it. And just in time for Halloween, there's a kind of a zombie apocalypse approach. And as you can see, that's a pretty daunting looking outfit that's wearing. I've no idea what the sort of person might be inside there. Oh, wait a minute, it's me. So I did get a chance to wear this 100 cal suit in a recent trip to a customer. And we were obviously in the building and it was fine. I mean, I can't imagine what it would be like wearing this outside in 100 degrees. It would be pretty brutal. This particular utility has decided this is their approach. And part of this presentation is to give you some ideas of how people are approaching this differently that we've seen and that we've witnessed. This is one approach. This is way and above over category 4. This is a 100 cal suit. I mean, this is an incredible suit. It's very heavy. It's very warm inside there. And so the way they try to protect you a little bit is to have, you know, a different way of approaching it is to put like little vents on it. I've got a picture shortly coming up about that. But this was the one of the meter techs who was wearing it. He wasn't outside doing a test. We were just wearing it just to see how it looked. He's not wearing gloves or any appropriate boots, work boots and electrical safety boots, but it's a pretty big suit. And that is an approach they've taken. They do not want to test. They want to test. It's important to them. They believe it's important, and they're going to run the testing, and this is their way of approaching it. It obviously affects them. It affects their training. You have to have, in their case, they have to have a secondary and even a third individual with them. They need to have access to any kind of 911 if they have an emergency or anybody overheats in this thing. So they really are very careful about this. And to try help them a little bit is this little vent on the back, which kind of does work. When I wore it, I could feel the vent on it. But really, I mean, if you're outside in 100 degrees plus, this is going to bring in the warm air. So I'm not sure that it's really an air conditioning system here, but it's trying at least to help you out. Quite an interesting experience, I have to say, that I'm wearing that one. And how I would work under that condition with everything else on it, I really don't know. But they've got themselves in a mindset. They've done it. They've trained each other. They've done some testing, and they're comfortable with it. And they've got some designated personnel that will be doing this particular test. So it's an interesting situation to look at. Okay, so how does it affect us? Well, one of the questions, of course, unfortunately, is always going to be a price point or financial. So here we are here, where I looked this up, and turns out this suit is about $2,000. I don't really. I mean, it's a question that we shouldn't be asking. There is no price on safety. There really isn't. But somewhere down the line, someone has to purchase this, operate it, make sure it's safe, test it regularly. So yes, that's part of the protection that one particular organization has chosen to go down. So there are other ones as well. I'll talk about that in some of the presentations coming up shortly. Okay, let's move on to a little bit of field testing issues, which is really why we're doing this presentation, because we as a company do a lot of testing with all sorts of different metering. And one of the ways that we do testing is we've introduced some new products now which will do live CT testing. That's important. It's important because the CTs that we can see in that picture on the left there are in a typical cabinet. We've gone through all the procedures, we've done the safe approach distance, we've done all the things that's required of us. Now we have an open cabinet, which is energized. And so we're approaching it carefully with our PPE, and we're going to do measurements. This is where it starts to change across the country. In California, at this point in time, they will not allow you to open that cabinet up. So it's going to be interesting how they're going to complete this task. They can do it with other methods, but this particular one that I just showed you with this large suit, this 100 cal suit, I don't know whether that's the most practical, but it's certainly a safe approach. And this is just a typical example of some of the field testing issues that we see. And this is with an energized load. And as you can see, you've got the three phases here with the buzz bars slightly underneath them, actually captured right through there, and you can see the cables. We're measuring CTs because essentially the meter that you've got on your installation or your service is going to receive all its current from this point. It's a transformer rated customer. So the incoming current going through the CTs, in this case phase A, is also going to output from the secondary, which is now going to go all the way through and into the meter itself. So the point about this is that's a very important part of the measurement circuit. If there's anything wrong at this point, other than catastrophic, which is not the case, but if there's a measurement problem or there's an output problem, or worst case, there's a reverse condition with these two wires, the meter really doesn't know that. More modern meters that are coming out are getting quite sophisticated, but they're also rather expensive to put everywhere. But the point being is the meter will just calculate the kW, it will calculate using its constant, it will give you the billing, it will give you the revenue. But if one of those is reversed, and I have seen it multiple times, where we've gone to a site that's never been tested before to find out that it was actually reversed from the day it was installed. This could be 10 or 15 years since they did the test. So now they have a problem in that they've identified a very low build problem here, which resulted actually in 66% less revenue for that installation. So it is a big problem if you find these, and that's the reason why we do these tests. We're trying to ensure that the customer is not underbilled or overbilled. Nobody wants either of those things. Excuse me. So just to re-emphasize what we're talking about, this is an energized system, and I've just highlighted a few situations down the bottom here on number 4. Approved gloves, we know that, in excess of 250. We're looking at suitable eye protection, and we're looking at each employee is exposed, which would include TESCO personnel if we're within the safe distance area, or the approach distance area, I should say. And there's all these different conditions about what you're meant to wear and what you're not meant to wear, including flame retardant, whether it's nylon, polyester, or rayon type of shirts. So we all equip our Tesco personnel with jeans. I get jeans, I got shoes, I got boots, and we have a fire retardant shirt as well that we wear. And we can wear gloves, and we also have helmets. So we approach this very carefully, and we all agree on the same thing, that this is it's not dangerous, but there is definitely risks when you do this. So we want to make sure that we don't expose ourselves to any undue currents or voltages. Excuse me again. So the CT in-service testing with an energized load. We have our flash conditions present. We're opening up a 277-480 cabinet. We have temperature conditions. I live in Arizona. I can tell you, having done this myself with a few of the local utilities, it is really not fun to be standing next to a cabinet where the cabinet itself is obviously really hot. That whole metal cabinet is going to get heated up to over 180 degrees. It gets very, very hot. And now you're wearing all your suit and everything. You've got to be real careful. However, access in here to wrap around the buzz bars. We want to maintain a safe entry and a safe exit, and of course, follow all the approach distance regulations. And I've seen this done many, many times, and it's done very safely, and we get very good results from that. I would say in the majority of cases, this is not a test you do every week. This is something you might do every few years, maybe once every 5 years, maybe once every year, maybe annually. You need to decide on which customers are the most vulnerable, the most sensitive, or perhaps also the ones with the highest load demand, and maybe their load changes significantly. That's when the CTs are being stressed. So it's wise to probably once a year, maybe pick those. It might be less than 5% of your entire customer base, but it's worth doing those. If you don't do them all, you don't need to do them all, but certainly I would focus on those ones that are perhaps the most sensitive. Okay, so an alternative CT testing with a de-energized load. This is something that came up a few years back when I was in a meter conference. We did a whole range of different topics, and I was talking about doing CT ratio testing and doing meter testing and a whole range of different burden testing that we were doing. And we got into a discussion about this, and it turns out that this particular company has also made an alternative decision, rather than using the suits, to actually enforce a disconnect notice on the customer and then advise them of what they're planning to do. Again, it may be once every few years, but nonetheless, the procedure would be to ensure no unsafe conditions and then de-energize the cabinet. And then with the approach again and making sure there's no arc flash in there, you're opening up a cabinet. You got to be careful when you open it up, all the oxygen's suddenly flying in there. So once they've established that, they can put the probes on. They then will back away and then re-energize the cabinet. Then they do the testing. They run the CT test. They'll run the probes. They run all the phases. They get all the measurements that they need. They will then de-energize and remove the probes, and then close the cabinet. And then the final sequence would be to re-energize and ensure the power has been restored. We got into quite an interesting conversation about this, and even between utilities, about whether this is even practical. It is possible, but I really don't think any large three-phase customers would relish the idea of having their production lines shut down and then re-energize and then de-energize them back on again. That's 4 sequences that they're going to have within an hour. So I'm not sure that the controlled outages like that, although they are controlled and they're safe and very little should happen, you're also energizing the switchgear, you're energizing everything else in there. So from a maintenance and service standpoint, that could be a problem. It's certainly the personnel are not at risk. There's definitely a positive there too as well. So it's a difficult one to decide. I know some friends, I live locally here near the world headquarters of Intel. And I remember having a conversation with one of the engineers about this, and he was like laughing so much he couldn't control himself. He said, can you imagine them shutting down this fabrication 16 micron wafer building and facility? It's impossible. It takes them 2 weeks to run this system up, and it takes them about 2 weeks to complete the process of generating all the chips that we use in our phones and we use in our equipment. and it has to be completely interrupted. So they go to an enormous degree of trouble to ensure they have 365, 366 days a year, 24/7. So that is just not going to be an option in that situation. So it's going to change depending on where and what your customers might be. Okay, what's another alternative we can use? I came across this again a few years ago. This is a very common approach for those of you in the industry, for those of you linemen, journeymen, or maybe meter techs who are involved in this. You probably recognize this particular probe. It is courtesy of SensorLink. We work with them. They're very well known in the industry. These are high voltage current probes. So they're measuring current like any kind of probe would. However, it can measure it up to, I think these days, something like 345 kV, the enormous amount of power. The benefit to using this, of course, is you are nowhere close to the actual cables and probes yourself. As you can see in this picture, I've got this journeyman alignment in actually a bucket truck. Now, this particular test has been done on an overhead service, which again is very common to use this. But what I didn't have a photograph, unfortunately, to share with you. But if you can imagine the same situation that you have there, where you're holding that hot stick, you have a fiber cable, a fiber optic cable, which is that little orange cable you see in the picture on the left, which will go from the actual hot stick, which is the U-shaped clamp, come down into that little sensing unit, which is on the base, and then that sensing unit will go to the measurement equipment. So it's basically doing the same thing as a type of Rogowski coil, but it's doing it from a distance, and that could be a 25, 30-foot hot stick. And what they're doing is they're opening up a cabinet, even if it's on ground level, and they're using the appropriate hot stick to go into the cabinet and make a single phase measurement, remove it, pull it back out again, put it back in, do phase B, and do the same with phase C. Now you can do 3 tests and you get the same results. So it's a bit more practical. It's certainly more approachable to do it that way. The high voltage probes, I would argue, are not quite as accurate as the Rogowski probes, but if you're getting a decent ratio measurement and you're comfortable with the results, you've achieved what you set out to do, which is to do a CT ratio check on that service. So it's definitely a practical approach, and I've seen a number of companies start to adopt this because they already have this equipment. The safety is maintained by the hot stick itself. You've got the approach distance, you've got PPE providing protection, and the fiber optic is enormously insulated. I mean, looking at something like, I think when I contacted SensorLink, it's like 100 kV per foot, which is huge. So you're not getting any risk at all from that fiber optic cable. Interesting approach, practical. We also will use those sensor links on our equipment too. So if the customer decides they don't want to use the standard probes that we provide, they could certainly use this. I've seen it done. I've actually experimented myself in safe environments in our factories and various places and meter labs where it's been protected and been given some training, and it works really well. So it just depends on, you know, the situations. And this is one of the issues that we're talking about here about this, is that everyone's taking a slightly different approach. Some are more practical than others, perhaps some more expensive than others, but they're all taking different approaches. So the alternative with that means that some of them are utilities are still going with the de-energized circuits, which we just talked about. Actually, this slide, it's my fault to put it in the wrong position, but I was just illustrating here. There'll be a demand on customers to accept full controlled outages to perform them. I don't know how that's going to go down. Why, you've got a good relationship with customers. You don't want to inconvenience them, but there are times when you may be required to do this test. It also adds a lot of strain on everything else with bypass switches and relays, load management programs. So I've just put a couple of questions at the bottom. Is it too risky? Is it too costly? These are the things that we need to consider when we're doing these sort of tests. Okay, let's look at some of the field testing issues, again, in a energized load using standard probes. This has been done for many, many years. This is a typical service panel with the meter, as you can see. And what we have is a test switch in the center there in that bar, which of course we're connected to with our duckbills, which go into the red, yellow, blue, which is ABC. And you can see the voltage connections. And then underneath there, you can see each of the A, B, and C phases with a double wrap on the cables, which allows us to get at least twice the amount of current in a low current situation or a low load situation. So in this situation here, we are gathering all the information that we're required to. We've got a three-phase test of the primary, three-phase of the secondary, ratio, phase angles, power factors, and we can do tests under customer load conditions or phantom load conditions, which is also very common, which is a full load, light load, and power factor test, and include harmonics and a whole range of other things too. So this is one, I illustrate this one because this actually happened only last week. And I don't decide how this is done. I don't decide how to approach this. I put myself in the hands of the utility I'm working with, and they guide me and they say, this is how we'd like to do it. Okay. And that's what we did. So it actually worked out pretty well. Just another quick example of what it would look like. It's certainly a smaller style of approach here. You're not involving a great deal of time. Not that, again, it's not a race here, but you want to get in and out fairly quickly to get more tests done. Typically, these are done maybe 5 or 6 or 7 a day on three-phase customers. And then that way you've got a really good asset management program that you've documented your testing. Everything's correct. You're getting the right results. And you're getting all the various checks that you need to get. And the instrument that we just introduced gives us all of these conditions, including an admittance and also what they call demagnetization, which we could do on perhaps another time we could do one and do a presentation on that one. When we run the test, we get a three-phase test, and this is just to give you an example of what it might look like. So as you can see here, meter test results. We can see here we got a customer load. This one was a timed run. So we ran this for a time and we get 100% 0.11, 100% 0.03, 100% 0.02, and all passes on them. So we get a standard run. The iteration means how many times you want to do this. You can do it multiple times. But this was done, it took them longer to install these connections than it did to run the test. And that's that is an important thing from when you're doing 5 or 10 of these a day. It does make the life of the meter technician significantly smoother to be able to go in, connect everything, run a test, and then go on to the next site. And like I say, safety is paramount. No one's going to make them and do any of this if there's a risk, and nobody does. And that's definitely a given there. We know that. And then once we have that, we can get a CT test, which is primarily why we're doing this. So this information here is really why we're doing all of this testing, which is why this OSHA regulation is going to impact how we do this, how we approach it, the regulations that may be required, the safety issues we all are familiar with. We've talked about those. But this is what we're doing this for, so we can give you a valid and traceable result that you can then take back, document, and then put into your system. Maybe go to the billing department and say, these are the CTs that we have, these are the tests that we have, these are the results that we have. We did it on this day, we did it on this time. We can do it next year or the year after. And that really is the screen. That's the one screen that you'll be wanting to use. Or that's the one bit of information that you will need. Okay. I did want to touch a little bit on these Rogowski coils. I know I'm slight side issue here from the safety, but this is not really a safety issue, but you are inside a cabinet, so it still applies where you've got to install these. There's nothing particularly wrong with this installation, except for the fact that, in my opinion, given the types of probes that we have here, you can see they've laid these onto the circuit board here almost, or the relay on the switchgear panel, the service panel. And you can see that the probes are wrapped 1 and then 2 and then 3. And you can see the different levels of cables here, but they're overlapping each other. That is absolutely not a safety issue. It's not a safety issue with these types of probes. However, it will cause a measurement issue. You need to have some little separation. These probes for this particular application are perhaps a little big. They perhaps need to move that one to one side, maybe get the middle one, move that one a little bit. It's not easy sometimes, and if you get the measurements okay, then that's good. But be aware that the amplitude of the phase can be affected because they're basically measuring 2 phases at this point. They're trying to measure this one and this one. So the snap connector also, which is plastic, is also leaning up against these connections here, which I wouldn't recommend. I would prefer it away from there, which is like that. So that's the same situation. where you can see much smaller ones, nicely wrapped, nice separation. Clearly, it's an easier access on this particular type of test. But the probes are separated. We've got spaces between them. We've got good amplitude. Phase correction is good. So it's just a practice. It's just what we do, and I certainly do when we do any kind of training with customers, try to encourage them to do this type of thing when they're doing the measurements. And then they'll get really good results when they do that. Just to finish, that's one of our new meters that's come out, and we will share that with everybody. This is a new meter to do all this type of testing, a pretty ruggedized case. We've got a very small, lightweight, portable unit that will do all this on batteries. No need to connect up a service panel. So it's a very quick and easy test. I've run a few tests already on this, and we're getting really excellent results. It's a pretty interesting unit, designed essentially to do this particular test. So we are going to see all our regional managers and all our tech support folks may well be going into the field to support customers out, which we love to do. They're going to have to understand about this safety approach. They're going to have to understand the OSHA regulations. They're going to have to understand what's required. And that's really why I brought this topic to this presentation, because it's not just about the testing, it's what we're doing as we're doing that testing and what exposure we might have. I did also speak to a couple of utilities who were telling me that there's sort of ongoing liability studies, which is understandable. I can understand that. They're trying to consolidate where they are with the testing procedures, and that's the decision they've taken in some cases not to test directly in the cabinet with 277 or 480. They're trying to implement new regulations. They're trying to follow the regulations of Cal OSHA, and that's an issue that's ongoing. I don't believe that's transferred anywhere else at the moment, but it may well do. I did some research. I couldn't find any other states. Certainly the state I'm in, they're familiar with it, but there are no regulatory requirements for them to do anything different than they don't do already, which is a very safe approach. So in conclusion, that's really essentially what I wanted to do with this particular presentation. It wasn't going to be a long presentation. It's about 35 minutes or so, close to 40 minutes. Wants to give everybody a chance to absorb it, maybe come up with some questions we might have, and we can move on to those questions if we wish. There is one more slide, I believe, which we have, which is illustrating some of the, is that right, Andy? Just the future upcoming TESCO presentations that we have?
That's correct. We have meter test switches next week, and you guys can all see the screen for the next few weeks. We actually run through December, and if you guys are not signed up, you can go to our website, tescometering.com/TESCO Tuesdays, and you can sign up for any of these. And if you missed any of these, you can also go to our website, tescometering.com, and go under conferences and presentations, and the presentations are on the website, or you can also search for it, or again, you can email us and we can send those to you as well, or send you the link to get those. So it looks like we have our first question from Daniel Taggart, and he asks, does the 6330 have an interface to Meter Manager to collect or store the results?
Yes, the product in question here is a next-gen product, and when we designed all of these products, we incorporated a similar software communication package. So the TMA software will be a part of this particular unit. We will have the ability to connect that to a system, and you can connect it into TMA and bring the data out, and then either export it perhaps as a CSV or a TXT file to another package that you may have. So it's really a bridge software in many ways. Or we have our meter manager software, which is a more asset management software that I mentioned briefly, which also communicate and bring this data in. So you can bring it either through screenshot samples, you can save screens and do the testing. So you're able to document everything you've done, including all the dates and times and who was doing the test. So it's a full, complete compliance test if you're service. But yes, the access to this is going to be through ports, communication ports. Well,
all right, and thank you for that question. We have a next one from Blair Hickman at SMUD. Is TESCO developing tools to provide additional space distance from energized parts? Do you want to answer that, or maybe we can have Tom chime in?
If Tom's there, sure, yes, why not? Absolutely.
Are you there, Tom?
Is he there? No?
maybe not.
Okay, well, yes, Blair, we are looking into that. We do a lot of the testing, as you know, and one part of the issues here is the approach distance. The equipment that we have
Tom, there's a question for you.
is just, she's just trying to probably get him because he's actually more inclined to know the details behind that in terms of the future. But great question. It is something that we know our equipment is going to be exposed. In order to measure a meter pulse pickup, we have to get close to the meter to bring that pickup in, and we have to get close to the cabinets. We can do a customer load test without the need to remove that panel. So it's possible to test the meter out without even removing the panel. However, you will not be measuring the CT performance. And that, we believe, is a component that needs to be tested at least periodically, whatever that period may be. So I can follow up with Blair and get some more details for him.
Okay, I think we tracked down Tom, and we'll see if he can hop on a second to
Sure, go ahead.
also.
Yeah. Okay.
So the question was, is TESCO developing tools to provide additional space distance from energized parts? We've started looking at some things like that. We've also started working. We already have put out some things like fuse jumpers and things, which were in a similar vein. It was a request from a safety standpoint. We could work out. Somebody else has just put in, what about longer hand tools to change out a class 200 meter in a safety socket type panel? There are additional hand tools that you could go. There are meter pullers that are out there. We've thought about putting a meter puller out there before. I don't know if anybody's ever used them or not, but they have vents in the sides. So should, God forbid, there be an arc flash, it would actually go out the side of the meter puller. We've talked about possibly doing something with test switches, although test switches are literally, since they're on the test switch, they're working on the lower voltage side of things. If you have an idea, if you have something that you're interested in, tell us. And, you know, if you've got something specific that you're interested in, tell us. And we will put it to, we have a very nice list of new products that a lot of times come from customers, or new features for existing products that come from customers. So please tell us. We do have the fuse jumpers. We are looking at two tools to extend the distance on site analyzer type things. But if you have anything specific, let us know. And also, I did mention the meter puller. We have looked at doing a meter puller. Does anybody, if you do use a meter puller, let us know. I know many of you have probably seen them. My understanding is most people may have them, but they're not typically used. But if you use it on a regular basis and you like it, please let us know. I'd be very interested in that as well.
Thank you, Tom.
And also to follow up, what about the longer hand tools to change out a class 200 meter in a safety socket type panel?
Right. Well, again, that's your meter puller.
Okay.
Typically is what you're going to be using. And yes, you could use other types of tools with insulated handles and make them a little bit longer. You absolutely could. Your meter puller is your best and safest way to do that, though.
Okay. Thank you, Tom. Does anybody else have any other questions? We'll give you a second to type them in.
Okay, so it looks like at least one person responded that they do use it in certain circumstances, the meter pullers. It does depend on the socket type. They do work really well, but again, they do take a little bit longer to use. They're a little bit more awkward to latch on, but they do work well. It's never going to be as fast as just going and yanking the meter, but they do work pretty darn well. Again, as I said, we've been asked a few times about it in the past. We have not released one. We have looked at it. Somebody else said something. Okay. Somebody's going to follow up direct with John Carroll about some issues that they've had when working with the Title 8 rules. And I think that's just about it. So we've been trying to keep it between that 45 minutes and an hour, because we certainly appreciate everybody taking an hour out of their Tuesday mornings. We really, really appreciate it. I think the upcoming session, the next one is the meter test switches. Andy, if you could go back to the slide right before that one. There you go. We've got coming up the meter test switches and then CT testing, theory and practice. We covered a little bit of that last week. And then we're going to talk more about ratio burden and admittance testing, kind of the difference between each of those and how you do them. And then we'll talk about asset inventory management in our world of IoT. Harmonics, complete site testing, electrical vehicle trends, so a little more current topics, as well as streetlights and 5G metering. So again, the whole idea here was this is effectively one full session of a meter school for intermediate, advanced, as well as current topics. So that's our goal. If you like it, let us know. If you didn't like it, let us know. If you'd like to see something else that we haven't put in, let us know. All right, John, thank you very much. Great job. Thank you, Andy.
Yeah, thank you very much, everybody. We appreciate it. Have a great day.
All right. See you guys. Bye-bye.
Bye.